problem 16.29. In this problem we are supposed to compare two sound waves that have same displacement amplitudes, but their frequency differs by factor r. So we say that f2 is some factor r times f1. Both A and B we can answer at the same time. So let's have a look at them. These are A and B. A asks which has the greater pressure amplitude, and B, by factor, it is greater. So first, let's state out what is pressure amplitude. It's defined by this equation: 2 pi times velocity of the wave, the frequency of the wave, and its displacement amplitude. And now we are asked to calculate the ratio of two different pressure amplitudes. So let's just do that. So PM2 is 2 pi V F2 times A divided by 2 pi V F1 times A. See that the only difference between these two sound waves is that they have different frequencies. Their pressure amplitudes are the same, and so is the velocity of the sound in the medium same. So everything else cancels out except F2 over F1, and we know what F2 is. It's R times F1. So the ratio simply becomes to be R, which is 1.9 in this case. So to answer the question, which has the greater pressure amplitude? It's the one that has higher frequency, in this case F2. And by what factor it is greater? It's greater by factor R, which is 1.9. Then C. Instead of pressure amplitudes, we are supposed to calculate the ratio of their intensities. And intensity is given by equation 15.7 in the textbook, which states the following: intensity of a sound wave equals 2 pi squared the velocity of the sound times the density of the medium, its frequency squared, and its displacement amplitude squared. So if we compare the ratio of two different intensities, remember everything else is the same except their frequencies. So for the intensity 2, we get 2 pi squared V rho F2 squared and amplitude squared. For I1, 2 pi squared V rho F1 squared amplitude squared. So again, a lot of things cancel out. These are the same, these are the same. So are their pressure amplitudes, or displacement amplitudes, as said here, they are equal. So we are left with F2 squared divided by F1 squared, which is same as F2 divided by F1 squared. And what is F2? We know that from the beginning it's R times F1. So this becomes R times F1 divided by F1, the whole thing squared. These cancel out. We are left by R squared. So the ratio of their intensities is R squared, which in this case is 1.9 squared, which equals 3.61.